I think recording started. Yeah, it has started. So today I'm going to be discussing Atcoder ABC task from A to E. I was able to do ABCD during contest, and I have absolved E just now. Yes, I'm going to discuss all of them and my protest towards these. So the first problem was you were given a string S and you were given a lowercase character, and now you get an English character which is or, and you want to remove all the characters which are present between any two S's. So this is pretty simple. You are given some string, let's say A, B, C, D, E, F, G, H. So you want to remove this part and you want all of these to be concatenated into a new string. So what I did was I kept a empty string and I kept track of the variable which indicates the count of these. If the count of this is 0, then I have to insert. As soon as I find this character, I increase this count by 1. And now up till this is 1, I don't have to insert anything. As soon as it turns to 2, I will check if the character that I'm inserting is not this, and I'll start inserting G and H. Let me show the code. Yeah, the code was this. You can see I took the input, then int x, which kept was a track of the number of these, and string answer denotes the final answer. And yeah, this was pretty basic, and I think it was like 400 level in terms of code forces. Yeah, moving on to the next problem. So the next problem is so I was given an n integers and I was not given n actually, and all I wanted was to print all the integers that I've taken in reverse order. So yeah, actually I did not know how to implement this, so I googled it, and I knew some sort of scanf or scanf will work, but and I had to use a do value, but didn't know exactly what EOF or backslash meant. And let me show you my submission. If you ask me to do it again, I won't be able to do it now. Yeah, basically copied it from I think CodeChef, and so I take an int x, which is my input which I'm taking, and this character denotes the this was a p character with respect to extracting it. So whenever I'm extracting x, what is the next character? If it is the end of file, that means that now I have to stop. I have stopped taking the input, and now I have to stop. And yeah, I just reversed the answer and printed it. This was again very pretty simple. Moving on to the next problem. So the next problem was ABC. So I was given three sequences A, B, and C, and for each of these sequences, I was given Q queries, and I had to see if it was possible to make a sum xi, which I was taking one element from each of these arrays. So there were two approaches to this problem actually. One was that I'm giving x, right? So now I could check for all. So now what I could do is I could subtract some part of A from this, then some part from BI, and then some part from CI. Let's call this K and K. If this equals to 0 anywhere, then my answer is yes. What I did was I pre-computed all the values of which the sum was possible as n was 100. So now I could just pre-compute if it was possible to create this value. What would I do if n was like 1000 in all of these three cases? If n was let's say 1000, in that case I would most probably do it in n square log n. How would I do it? I would keep all of them in sorted order AI, BI, and CI, and then two rows would be used for AI and BI, which would denote AI and J, and for C I would use binary search rows probably, right? So this would take me off n square log n. There is no way I can do it in less time, obviously. What I did was it was pretty simple and pretty easier to code as well. Okay, so let me show what I did. I just pre-computed all the sums which are possible using AI, BI, and CI, and checked if and stored it in a map. and then I checked if it is possible to create that sum or not. If the sum that I'm taking, which is a query, is present in the map, then my answer is yes, otherwise my answer is no. Okay, moving on to the next task. So next task was a pretty interesting, and it took me a while to actually get to the answer. That's why I was unable to do E during contest because wasn't left with much time. So basically, this problem states that you are given an initial string and you get given a final string, which is, let's say, T, and you're given an initial string S, which is initially empty. Now you're also given some vector of some list of strings, some matrix of strings. Okay. Now you want to check if you can, for from each row, you have to select like one of these, and you want to know if you can create the final string. That means, for example, if I take AB and then I take BC and then I don't take this, and my final string is ABBC. Is it possible to create it using each of these values just once? Yeah. So uh, what I did, so this was actually a question which I was not sure how to implement it because it looks like it is some like you have to move the indices. So one state is that, and the for the other state you could have a variable which keeps track of the count of the character at which we are actually present. That means A, B, B, C. Um, so J will donate 0, 1, 2, right? But again, this is constantly changing, and whenever I'm adding substring to the string T, the T would change by a different amount, and that would make the complications very harder. So what I did was I kept a track. I just did a recursive function for this one. So in the recursive function, what I had passed was the string, which was let's say str. This is the new string that I'm creating, and then a variable jj, which denotes the index at, let's call this index only. So index will denote at what row of the matrix I'm currently present. For example, if in this A B C D E, and here it is A B A B C and F C B C D E, and then finally E. So now initially GG index would be 0 and string would be empty. Now if I take A, I would increment I by 1, and now I becomes 1. This would ensure that I am not taking anything more from the first row itself. So now I have A B A B C. Let's say I've taken E, and now if I would not take F, and then I move forward. I won't, and I take E, then it is possible. Okay. What would be? Yeah, this is the simple recursive function. Okay. Let me show the code. Uh, okay. Yeah. So I was getting a TLE in this. Let me show you what I had previously done. So I just passed in the recursive function, which was just like so if my the size of the t, which is the final string, is less than if my the string that I'm making exceeds the string, the final string, that means this answer is false. And anyway, if I keep on adding, I won't be coming to a point where I have lesser characters. So that means I have returned int max. First I have taken input in the form of a vector of string adjacency. This is like a graph. Then I passed in the function 0, t, adjacency s. S is the empty string that I am creating, T is the final string, adjacency is the matrix, and JJ is the index. So JJ ever becomes equal to N, that means the string that I am trying to make is not possible. I am returning int max. Now I done like int x equals to int max. Int max means that I am just there must be some number of steps which actually form to which actually will form the string. So every time I'm adding, it would be 1 plus the previous number of steps. And if I'm unable to make this, this would be some countable number, otherwise it will be into max. Alright, yeah. So I did this. Now the thing is that I had to memorize it. So there were two, what do you think are the states in this? Take a minute and try to think it yourself. Now I will tell you the answer. The states are in this are the string t which I am trying to make, which is str, and the index at which I am currently present. Let's say because it is possible that I can go from the same state I can reach like multiple times. I can pass like multiple times. So that's why I'm taking this state as STR for my index. This actually took me quite a while to understand why the states would be STR and index and not just simply STR. I would want you to think by it for yourself, and I'll show you the final code which I had implemented. Yeah, a lot of wrong answers. It took me about 9 wrong answers to finally get to it. Yeah, so I had memorized it using a map in which I was passing pair of string comma 8 and the answer as a form of 8 because I cannot memorize it using a simple vector a vector or an array, right? And this is the memorization part. If this state is previously occurred, then just return that value. Otherwise, pass whatever the value is coming as answer into the string. And as you can see, this passed all the test cases and didn't took quite a long time. Okay, so now coming on to the problem E. So I wasn't able to do it during contest, but but as soon as I saw it, even after the contest, I got the intuition of how it has to be done. Okay, yeah. So basically, you're given Q queries up there of the form. Let's say you're given like A and N integers, and now you want to insert X after Y. So it is guaranteed that X is present. You want to just insert Y immediately after element X in the array. That means if my array was something like 1, 2, 3, 4, 5, and I want to insert 6. So what I would do is 3 and then 6, and then so my new array would become 1, 2, 3, 6, 4, 5. Alright. Or you could have another query in which you have to delete elements. So let's say I'm giving you query 2 comma 2 and you want to delete 2. So you would just delete this and this becomes 1, 3, 6, 4, 5. So the naive approach to this problem would be to like 1, 2, 3, 4, 5, and I want to insert 6. So you break it into two parts, which would be this and this, and then you insert this and then you form a new array. So this operation would take O of n time. Alright, although the fetching would take O of 1, but the actual implementation of this insertion would take O of n time because I am trying to subvert it. But since q is of the form 2 into 10 to the power 5 and n which is almost equal to n, so I cannot do it. So that means I have to do something else. Now there is a very basic and simple data structure which is used by almost everyone when they are trying to learn DSA. Take a moment and try to think of what data structures can be used. Let me give you a hint. The hint is that visitor can perform insertion operation in O of 1. Alright. You can insert anything to it at the end in O operation of 1 time. Alright. Although the fetching operation is O of n, but the insertion is O of 1 only. I think you all might have guessed it right. The answer is that we are going to use a linked list. Alright. And why a linked list? Actually, to be particular, we'll be using a doubly linked list. So why a doubly linked list? Because in the doubly linked list, let's say I am given 1 and this is previous 2, 3 and 3, 4. Okay. So now let's say if somehow I can get that the node which is pointing to in which 3 is present is like let's say 10, right? So now I can just remove 10 by making its previous next as next and its next previous as 2. So now all I have to do is just shift these arrows, remove this, and this can be done in O of 1 time because I already have to data of 10 ka previous and next. Alright. Yeah, so I think things should be clear. So now try to implement it yourself. I will show you the code. Okay. Yeah. Okay. So first I have created a node. This is the format that I use for creating a node, which is like in data, then next previous. This is a constructor when I'm initializing the value of the data part. Okay, and now this is an insert function, which is simple insert it into the doubly linked list, because I had to do it n number of times while I was creating a doubly linked list. So first I took in the array and then I inputted it. After that, what I did was I kept track of the head part. Head portion initially pointed to the first element of the array, and now MP of air of 0 is equals to head. Okay, this means what my MP is doing. So basically, MP is for fetching the node in lesser time. Otherwise, it would take me order of n. Now this operation takes me order of log n. Okay. Also, there is one assumption that I've taken in this portion is that all the things in this present that are actually queried are unique. If they are not unique, then I don't know how can we do this. Probably I would have to create an adjacency list instead of a doubly linked list or a map of adjacency list. Okay. So this is some insertion portion, and then I pointed my head to temp1, which is temp1 was my initial head, because now after if I check the value of head is now pointing to null. Okay, now we move forward. I take in the queries, and now I think the implementation is also very simple, and you just have to be careful about this portion, like what if next is equals to null, what is previous not equal to null. Okay, so you got the index where like in the first, so in this you have got the, so इसका मतलब है कि तुम्हें x के बाद वैल्यू सेट करना है, तो तुम्हें x का पॉइंटर मिल गया टेम्प में, ठीक है, बिकॉज ऑफ द मैप विच है प्रीवियस नोड, तुमने एक नया नोड बनाया टेम्प वन। अब तुम देखोगे टेम्प का नेक्स्ट है, मतलब टेम्प फाइनल नोड नहीं है, तो मैं क्या करूँगा नोड के नेक्स्ट में टेम्प का नोड का नेक्स्ट पॉइंट करता है टेम्प के नेक्स्ट को, ठीक है, और टेम्प का नेक्स्ट हो जाएगा टेम्प वन। टेम्प का नेक्स्ट समझ लो, टेम्प के नेक्स्ट का मतलब है कि मेरा जो नेक्स्ट है अब वो टेम्प वन हो गया है, ठीक है, मतलब कि मान लो मुझे टू के बाद थ्री डाला था ना, टू टू के बाद फोर फोर डाला था, पहले थ्री था, टू के नेक्स्ट में मैंने फोर डाल दिया, ठीक है, टेम्प वन प्रीवियस में टेम्प डाल दिया, फोर के प्रीवियस में टू डाल दिया, टेम्प वन के नेक्स्ट में नेक्स्ट डाल दिया, फोर के नेक्स्ट में थ्री डाल दिया, थ्री के प्रीवियस में फोर डाल दिया, ठीक है। अगर वो टेम्प का नेक्स्ट नल हुआ तो मतलब ये ऑपरेशन नहीं करना है बस, ठीक है, मूव ऑन। और फिर फाइनली हाँ इसको स्टोर करना जरूरी है, वरना तुम्हारा आंसर टी रन टाइम है, क्योंकि उसके पास प्रेजेंट ही नहीं कि डेटा प्रेजेंट का, ठीक है। अब मान लो डिलीट करना है वन टू थ्री फोर फाइव, मान लो टू को डिलीट करना है, तो मैं देखा टेम्प का प्रीवियस है, उसने कहा हाँ टेम्प का प्रीवियस है, तो अब मैं क्या करूँगा टेम्प के जो प्रीवियस है उसको स्टोर कर लिया वन, टेम्प के नेक्स्ट उसको लिया विच इज थ्री। अब मैं क्या करूँगा वन के नेक्स्ट में थ्री डाल दिया, थ्री के प्रीवियस में वन डाल दिया, बस खत्म, और उसके बाद में फ्री कर दिया टेम्प को। अगर टेम्प के प्रीवियस में ऑलरेडी नल प्रेजेंट है तो मुझे कुछ करना ही नहीं है, तो मुझे सिर्फ इसको हेड बना देना है which is temp का next. Okay, yeah, so that's it. I was able to do till this only, which is I was able to do till E. All right, let's see the ratings. See, this is taking some time to load. Okay, I guess it's a net issue. I don't know why it's not opening. See list के कुछ प्रॉब्लम है इसलिए ओपन नहीं रहा। Anyways, I think all of these were around less than 1200 ratings in terms of code forces, and I think F was some, yeah, it was some graph problem, graph, and yeah, it is some hard graph problem. Maybe I'll try it now, although I haven't reached to the point where I'm trying F. Okay, yeah, so yeah, that's it for this video, and keep watching. Thank you.